Good morning, students. Last class we discussed about what is the induction motor, why the induction motor will be widely used in industries, what are the advantages of induction motor, what are the disadvantages, and also what are the applications of three-phase induction motor, and then construction of three-phase induction motor, stator, rotor. Again, rotor may be classified into two types. So, slip ring type of induction motor, squirrel cage type of induction motor. And the difference between those two also we have to discuss it in the last class. Now, we go for the next topic, that is production of RMF and also principle of operation. Production of RMF, production of rotating magnetic field, and also principle of operation. So last class we discussed the what is the principle of operation of three-phase induction motor is nothing but mutual induction, electromagnetic induction principle. That means we are giving a three-phase AC supply to the stator. So in that stator, so a rotating magnetic field is produced that may lead to production of rotating torque in the rotor, right? So now this production of RMF, how the production of rotating magnetic field is produced, how to discuss in today's class. Generally, when a three-phase AC supply is given to the stator, a rotating magnetic field, otherwise the electromagnetic field, will be developed in the stator with and that rotating magnetic field is rotating with a speed of ns, that is synchronous speed, and that ns is equal to 120 F by T. Numerically, it is a 1500 RPM. That means whenever and three-phase AC supply is given to the stator, in that stator a rotating magnetic field is produced. That rotating magnetic field is rotating with a speed of synchronous speed, that is ns is equal to 120 F by P RPM, otherwise 1500 RPM numerically. Now let us consider how the RMF is produced. We have to discuss now. That's why now let us consider phi m is the maximum flux. Phi m is the maximum flux. Phi r is the flux produced in the phase R. Phi y, phi b are the fluxes due to the y, b phases respectively. That means phi r, phi y, phi b are the fluxes due to r, y, b phases respectively. We know that three-phase system, total the angle is 360 degrees by 3 is nothing but 120 degrees. So each phase will displayed with a phase angle of 120 degrees. Suppose we have to take in R phase is the reference. That means the phase angle of R phase is 0 degrees. Now from that 0 degrees, 120 degrees, the Y phase is displayed. So from that Y phase, again another 120 degrees, B phase introduced or displayed. That means from R phase, Y phase is 120 degrees, B phase is 240 degrees. Suppose from R to Y phase 120 degrees, Y to B phase also 120 degrees. Like that also we have to do. Now we have to take in the three-phase waveform circuit. Look at the picture. The R phase will be starting at the 0 degrees, and Y phase will be starting at the 120 degrees, and B phase will be starting at the 240 degrees. So this is the R phase ER, and this is the Y phase EY, and this is the B phase EB. Now we have to represent the waveforms, the empirical formulas. Phi r is equal to pi m sin omega t. Generally sin omega t minus 0 degrees. Why? Because R phase will be taken as a reference. That's why the phase angle is R phase 0 degrees. From that, after R phase, so 120 degrees after R phase, so Y phase will be introduced. That's why pi Y is equal to pi m sin omega t minus 120 degrees. Similarly, B phase, from R phase, B phase is started after 240 degrees. That's why pi B is equal to pi m sin omega t minus 240 degrees. So pi R, pi Y, pi B. Now to take in the equations, flux, the equations of flux due to R, Y, B phases respectively. Right? Now, look at the picture clearly. Now, suppose we have to calculate the resultant flux at a different instant. So at any instant of time, the pi r resultant flux must be same. Then only we have to develop a unidirectional torque in the rotor. Suppose when omega t is equal to 0 degrees, omega 2 equal to 0 degrees. Substitute that omega t equal to 0 degrees in the above equations. Above equation is nothing but these equations, these three equations. 1, 2, 3, you can consider. Let us consider 1, 2, 3. So substitute 0 degree in place of omega t, substitute 0. Pi r is equal to 0, sin 0, 0. So pi r is equal to 0. And this is omega t 0. Pi y is equal to pi m sin 0 minus 120. Sin of minus 120 minus sin 120. Right? And sin 120 is sin 90 plus 30. That is cos 30. That is 0. Minus 0.866. Already minus is there. So minus to minus plus. So pi y is equal to minus 0.866 pi m. Otherwise, minus root 3 by 2 pi m. Next, pi b, sin 0 minus 240 degrees. That is equal to root 3 by 2 pi m. Now, look at the phasor. Here, phasor diagram is important. Taken as pi r as the reference, that is the 0 degrees, and pi y is displaced 120 degrees apart from the pi r, and from pi r onwards 240 degrees, that is the pi b. Pi r, pi y, pi b are the three phases displaced each one by 100 degrees. Now omega t equal to 0 degrees. That means, so I am taken here pi r is 0. Pi r 0 is nothing but we don't take in this one. This is initial one and reference one. Now, pi y minus root 3 by 2 pi m. So this is the pi y. What about minus pi y? Exact opposite to the top pi y. So this is minus pi y. And pi b is a positive value, root 3 by 2 pi m. Now we know the values, these two, pi b and pi y. What is the angle between pi b and pi r? 120 degrees. In the middle, that is 60 degrees, right? So the vector sum of pi b minus pi y is nothing but pi resultant. That is equal to pi resultant is equal to pi b square plus minus pi y square minus 2 pi b minus pi y cos 60 degrees. What is the pi b value? Root 3 by 2 pi m whole square plus what is the pi y value? Minus pi y value. That is also root 3 by 2 pi m whole square plus here already minus is there, minus plus 2 pi b root 3 by 2 pi m root 3 by 2 pi m, right? Cos 61 by 2. Now here 3 by 4 pi m square plus 3 by 4 pi m square plus 3 by 4 pi m square. So 3 by 4 plus 3 by 4 plus 3 by 4, 9 by 4. 9 by 4 pi m square. Here square not is there, but we have to put square, pi m square. 9 by 4 pi m square, square root. Square and root will be cancelled to each other. Sorry, square and root cancel to each other. That means pi m. What about root of 9 by 4? Root 3 by 2. So the, sorry, 3 by 2. Pi r resultant is equal to 3 by 2 pi m. That is equal to resultant flux pi r is equal to 1.5 pi m. 1.5 pi m. Resultant flux pi r is equal to 1.5 pi m. Now take in the another case. 60 degrees. Omega t equals 60 degrees. Listen for this. This is also important question. Sometimes they are asking. So for this question, this phasor diagram is important. Right? Once again, please clearly listen. Omega t equals 60 degrees. So omega t 60 degrees is substituted in the above three equation, that is pi r, pi y, pi b. And we are getting the values like this. Pi r equal to root 3 by 2 pi m, pi y is equal to minus root 3 by 2 pi m, and pi b is equal to 0. So here pi b is 0. As usual, we have to draw the three phases, each one displayed with 120 degrees. That is equal to pi r followed by pi y followed by pi b. Three are displayed to each other by 120 degrees. Now coming to these equations, pi b 0, so pi b 0, neglect it one, and pi r plus root 3 by 2 pi m, and put same as pi r. Pi y minus root 3 by 2 pi, that is minus. So we are getting minus pi y is nothing but exact opposite to that of pi y, that is this is the minus pi y. Now vector sum of these two is nothing but resultant flux. Pi r is equal to square root of pi small r resultant equal to square root of pi capital R square plus minus pi y square minus 2 pi r minus pi y cos 60 degrees. As usual, again resultant flux is equal to 3 by 2, that is 3 by 2 pi m, that is equal to 1.5 pi m. Suppose we go for omega t equal to 120 degrees. Again, this 120 degrees substitute in the above three equations, we are getting the values like this. So in this case, y must be 0. That means pi r is positive, pi b is negative. So we have to draw the phasor diagram as usual. Pi r followed by 120 degrees after pi y. After 120 degrees of from pi y is pi b. Now here pi y 0, neglect pi y, and pi r is positive, put as same. Pi b negative, that means so minus pi b is nothing but exact opposite vector of pi b. So now vector sum of these two, that is pi r minus pi b, is nothing but pi small r, that is also 3 by 2 pi m, that is equal to 1.5 pi m. So at every case, at every instant of time or at any case, we are getting the resultant flux is 3 by 2 pi m, that is 1.5 pi m. Suppose we are going for the 180 degrees. 180 degrees, pi r sin 180 is 0, pi again pi r is 0, pi y root 3 by 2 pi m minus pi b minus root 3 by 2 pi m. That means in this case pi r is 0, you can neglect it. Pi y positive value, you have to draw in one side, so this is pi y. Pi b means minus root 3 by 2 pi m, that is nothing but exact opposite to that of pi b. Now vector sum of these two, that is pi y and minus pi b, is nothing but pi small r, that is also 3 by 2 pi m. So at any instant of 0 degrees, 60 degrees, 90 degrees, 120 degrees, 180 degrees, whatever it may be. So it is clear that at any instant of time, the resultant flux is same. Sorry, the resultant flux is same, that is nothing but 1.5 times of the maximum flux. The direction of the RMF in the stator core is in clockwise direction, and this magnetic field is rotating with a speed of ns is equal to 120 F by P. Next concept, that is equal to working principle of three-phase induction motor. The mainly three-phase induction motor works on the principle of induction. So whenever a three-phase AC supply is given to the rotating magnetic, whenever a three-phase AC supply is given to the stator, a rotating magnetic field is produced in the stator. Look at the picture A. After giving the supply, three-phase AC supply, rotating magnetic field is produced. And this rotating magnetic field, omega S, this is the rotating magnetic field, will be rotating with a speed of synchronous speed, that is 120 F by P. So look at the pictures. Here the rotating magnetic field is produced. The rotating magnetic field is same at any instant of time, and totally resultant of flux will be flowing from stator to rotor. The production of RMF cuts the stator rotor conductor, and an EMF is induced that will cause a current will passes through the rotor conductors. That is production of rotor current produced in the rotor conductors called rotor current. Now the direction of magnetic field by skew rules or right hand thumb rule will be decided. Now because of interaction of stator flux and flux around current rotor conductors, the flux is strengthens right side and weakens the left side of the rotor conductors as shown in figure C. So look at the figure C once. Look at the figure C, that is the resultant flux that may be strengthened one side and weakened one side, right? So that is the point. This result in movement in the rotor in anti-clockwise direction. From the above discussion, it is clear that an induction motor is a self-starting motor. So if once you are giving a three-phase AC supply to the stator, that may develop a three-phase rotating magnetic field that is rotating with a speed of synchronous speed, ns is 120 F by P RPM. Now this rotating magnetic field will flowing through the rotor through the air gap and will cut the rotor conductors. Then in rotor conductors an EMF is induced. Now because of this induced EMF, current will passes through the rotor conductors called rotor current. Now because of interaction of stator flux and flux around the current conductors, the flux is strengthens in right side of and weakens left side. That means they develop some force on the conductor. Now twisting moment of the force or turning moment of the force is nothing but torque. Now this torque for single conductor, so torque for number of conductors, that means a force will be developed. The rotor will rotate the motor with some speed, but it does not running with synchronous speed. It may running with lower than the synchronous speed or higher than the synchronous speed. Always the rotor always attains to reach the synchronous speed, but it does not meet the synchronous speed. Suppose if it meets the synchronous speed, the relative speed between the rotor and stator must be 0, that is ns minus nr equal to 0. So automatically the torque must be 0. So now the rotor will again comes down to it will rotating with a small speed. Again it will be attaining a speed and it reaches the synchronous speed, but it does not reach the synchronous speed. Like that the process will be continuous. That's why even though torque is 0, again it will be re-energized. That's why three-phase induction motor is a self-starting motor. And also three-phase induction motor is a asynchronous motor. Why? Because it is running with lower than synchronous speed, or it running with higher than synchronous speed, but not at synchronous speed. That's why the three-phase induction motor is a asynchronous motor, and the three-phase induction motor is also called as a it is a self-starting motor. Three-phase induction motor is a self-starting motor. Right? Thank you one and all. To see this video, please subscribe DBS Talks. Next class, we discuss about the slip and their effects on different parameters. What is slip speed, and what is the slip variation with load, and rotor parameters, slip on different rotor parameters. That is rotor frequency, rotor current, rotor power factor, rotor induced EMF. Like that, we have to discuss next class. Thank you one and all. Please subscribe DBS Talks.